I went to KFC suddenly to eat. So yeah, we have to continue now only. It's about 10 over here. Maybe it's still 1 hour we will be taking this video. Then we will have a pass. Pass and then we will be completing this video. Okay. So you are having, if it is sine square theta plus cos square theta is equal to 1, then in terms of A you have to write, in terms of B you have to write. So you have already here cos A, then write with respect to, then you have to know sine A. Okay, so sine square A is equal to 1 minus, what is cos square, sorry. Here in terms of B you have to get. Okay, so sine square A is equal to 1 minus cos square A. What is cos square A? Cos square A is equal to x square. Okay, so in terms of just sine A, so that means sine A is equal to root over 1 minus x square. Here you have to find sine B. Okay, sorry, sine B only you have to find. Sine B is equal to root over 1 minus y square. Okay, so you have got sine A, sine B, cos A, cos B. All you have to do is you have to give input. Okay, to which formula? In the very beginning, even I said this one formula, right? So cos of A plus B is equal to cos A dot cos B minus sine A dot sine B. Okay, so this is the formula. We know this formula. So you have to give input. Before giving input, what you have to do? No, first you give input, then we will be doing the reciprocal. Okay, then we have to reciprocal, and then you have to multiply this total equation with respect to cos inverse. Okay, so first, or also, yeah, now even we will first do cos inverse. Okay, if you're doing cos inverse, then the resultant equation will be A plus B is equal to, here totally there will be cos inverse. Okay, so cos inverse of cos A dot cos B minus sin A dot sin B. Okay, so sin A dot sin B. This is what you have got. Okay, so this is something that we have got right. Okay, so cos A, what is there? Cos A is equal to x. So first A plus B, first from A plus B will be starting. What is A? It is cos inverse x. Okay, so next is what is B? B is cos inverse y is equal to what? Is equal to cos A. What is cos A? X. What is cos B? Y. Oh God. Okay. Minus. So minus. What is sin A? Sin A is going to be root over 1 minus y. 1 minus x square. Root over 1 minus x square into. Okay. What is sin B? Root over 1 minus y square. So this is what the formula that you are going to get last. Okay. So I'll write this formula in this color itself. Okay. Very neatly. Cos inverse x plus cos inverse y is equal to cos inverse of x into y minus root over 1 minus x square into root over 1 minus y square. Okay, so you have got this equation. Next, secondly, we are going to, secondly, thirdly. Tan inverse, okay, tan inverse of x plus tan inverse of y is equal to tan inverse of of x plus y whole divided by what? Whole divided by 1 minus x into y. Okay, so 1 minus x into y. Okay, how will you prove this? See, very simple. Only one trick I'm saying. Okay, one trick. This is not even a trick. It's something that you would already know. Cos inverse of x plus y, cos inverse of x plus cos inverse of y is there, right? For this you have used this formula. So for sine inverse of x plus sine inverse of y, you have used this formula. Okay, sorry, which formula? This formula only you have used now. So for every trigonometric thing, you are going to use their own respective additional formulas. For every inverse trigonometry, you are going to use their own respective normal trigonometric formula only. So for this, which formula you are going to use? You are going to use okay. So you are going to use tan of x plus y is equal to tan x plus tan y whole divided by 1 minus tan x dot tan y. Okay, so this is what you are going to use. This formula already where we have seen. Okay, here even we have seen very clearly, right? So that formula is what? This formula already in the last seminar even I've told you. Okay, so how will you prove? Exactly the same way only we are going to prove this one also. Not only this one, also cot is also proved by the same way only. How? Let tan inverse of x be A and tan inverse of y be B. Okay, so then tan A is equal to x and tan B is equal to y. So you have got tan A, you have got tan B. Then what you have to find? You have to find, yeah, you have got tan A, you have got tan B. So then what is this? First you are going to put them in their respective equations. Equations in sense their respective formulas. Okay, so this is what their formula now. So tan, which color shall we use? We shall use this color. Okay, so tan of A plus B, tan of A plus B is equal to tan x. Sorry, I think I've considered them wrongly. Yeah. So you have to keep tan. No. Tan A is equal to x. Okay. Tan A is equal to x, tan B. Okay, see, here this representation is not that important. That means what am I saying? Sorry, even I got confused. OMG. Here instead of here x plus y, you can also give here alpha plus beta. Okay, you can also give here alpha plus beta. Any angle you can give here. The representation is actually why I have given here just x plus y. You start to represent that it is a formula. Okay, it is a theta. Okay, this is what a theta is. It can be this x plus y can be also written as a plus b, this a plus b, or this x plus y can be written as alpha plus beta. Any notation can be used in order to represent that particular theta. Okay, that particular angle. So here tan a plus b is equal to what? Tan a. Okay, so tan a is x plus tan b. What is that? Y whole divided by 1 minus x dot y. Okay, so now what you have to do? Very simple. This and this is okay, and then this same only now. All of them are same, right? So that means only one difference here. Tan inverse is not there. Here tan inverse is not there, and here tan inverse is there. So what you can do? You have to multiply this total formula with tan function, okay, tan inverse function. So then automatically you'll be getting the desired formula. Okay, so if you're multiplying this total equation with tan inverse, then the tan inverse and this tan will be cancelled out. Yes, right. So it will be just the a plus b. Okay, so that means if it is just the a plus b, what is tan a? Okay, what is tan a? Tan a is x. Okay, wait, it is just going to be a plus b. Yeah. What is a? Tan a is tan inverse of x. Correct, right? So tan a is tan inverse of x. So I can write here it as tan inverse of x. What is b? B is going to be tan inverse of y. B is going to be tan inverse of y plus tan inverse of y. Since we have multiplied this total equation or this total formula with tan inverse, so here tan inverse is going to be there. Tan inverse of x plus y whole divided by 1 minus x dot y. Okay, so this is what the formula that you have got. Now, next we are going to prove other formulas. Other formulas in sense what? We are going to prove cos inverse, okay, cos inverse x plus sine inverse x is equal to pi by 2. Okay, so cos inverse x and sine inverse x is equal to pi by 2. Note, okay, note this one point, that this radian and this radian should be same. That is why I have represented here also x, here also x. Okay, so how are you going to prove this? How are you going to prove this? Okay, very simple, very simple. What you are going to do? Think a little bit. Here tan inverse of x is there, here sine inverse of x is there. As usual, what we have to do? We have to assume that, okay, cos inverse of x is equal to theta, let us assume. Okay, and also we will assume that sine inverse is also equal to theta. Okay, so sine inverse of x is also equal to theta. Okay, so these two are equal to theta, right? Okay, so then sine theta is equal to x. Okay, so sine theta is equal to x. See here, this, okay, the sine theta is there. Okay, so the sine theta is there. We have got sine theta. Let us just imagine that you know only sine theta. Okay, you don't know what is this cos theta. Sorry, before I said that, you know, right? Okay, so let us imagine that you know this one. Okay, and you don't know this one. We are actually proving this one only, but since with respect to the proving point, if I am explaining that, then you will be able to catch this very easily. Okay, so we can write sine in terms of cos also. How? How can we write? I already said this conversion, right? I already said those conversions, that is x is equal to cos, okay, of pi by 2 minus x. Okay, pi by 2 minus x. If you are writing like this now, then you will be getting this. X is equal to cos pi by 2 minus x. How? Here even I have explained all those conversions. Okay. So I've got, sorry, here sin x. Okay, so sin x is what equal to? Oh, sorry, I was feeling fasty. Oh, so there is a mistake. How? We cannot write here sin x now. It will be just x. How? How? See, here sin theta is equal to x. Okay, here it is okay. As I said that you can convert sin theta into cos theta by using some formulas. So here, how will you convert this sin theta into cos theta? Very simple. So cos theta pi by 2 minus theta. Okay, pi by 2 minus theta. How? Why here minus? Why not plus? Because minus theta na, okay, so pi by 2 minus theta na, it will come over here. Here this is actually positive, which is positive. All trigonometric functions are positive. Okay, so that here everything will be positive. Even here also all silver only. So here also it's okay. Even if you put here plus, also okay only. But minus is preferred. Your wish. Minus or plus, it's okay. No, minus only. Then only you'll be getting this formula. If you are putting minus only, you'll be getting this formula. See, pi by 2 minus theta, pi by 2 plus theta. When you are having pi by 2, sine pi by 2 plus theta is also equal to cos theta only. Sine pi by 2 minus theta is also equal to cos theta only. But the thing is, if you are using minus theta only, you will be getting the at last derivation of the formula. Okay, the last derivation. This required derivation you will be getting. If you are using plus, then you will not be getting. Okay, so cos theta, how here theta will be coming? OMG, what am I writing? Okay, so cos pi by 2 minus theta is equal to x. Okay, so is equal to x. What is x? X is equal to sin theta, na? So we will put here sin theta. Sin x is not allowed, but sin theta is allowed. So cos, put cos inverse. Okay, so put cos inverse. Put cos inverse. You have to multiply this total equation with cos inverse theta. Okay, so here after only the important bigger steps comes. Okay, important bigger step comes. What is that? So you have to multiply this total equation with cos inverse. So that means here it will be pi by 2 minus theta is equal to cos inverse of x. Okay, is equal to cos inverse of x. Okay. You have got this. What is theta? Theta is cos inverse of x. Theta is cos inverse of x. So pi by 2 minus cos inverse of, okay, cos inverse of x. Okay, ma. So is equal to cos inverse x is equal to cos inverse x. So pi by 2. So here I will be writing the last formula. Okay. So if you are transposing this to this side, then you will be getting this formula. Okay. So this formula is derived. Okay. This formula had been derived. Now we are going to derive other two formulas in the same model. There are totally still some other formulas also in the same model. We are going to derive them also. Like sec inverse x plus cosec inverse x is equal to pi by 2. Tan inverse x plus cot inverse x is equal to also pi by 2. Okay. All these have the same type of derivation only. Now we are going to see them. What is that? What shall we see? Now we will see tan. Okay, so tan inverse x plus cot inverse x is equal to pi by 2. Okay. So amongst them you are going to choose like something you know, one thing you know. Okay, amongst them one you already know. So what are we going to choose? You choose tan itself. Okay, you choose tan itself. Okay, here tan. And in sec and cosec you choose sec itself. Okay, you are going to choose sec. Correct only. Okay, just a blind guess. I don't know even why I said that. Well, I did see notes to confirm them. Okay, or in order to clarify whether can we choose cos over here. Okay, here we have chosen sin inverse x and we have derived this formula. In order to clarify, we will also select cos. Okay, we will also select cos and we will see. Okay, ma. So then cos inverse x is equal to theta. Okay, so cos inverse x is equal to theta. You keep. So then absolutely cos theta. Okay, so cos theta is equal to x na. Okay, va? So how are you going to convert this? You can convert cos theta into sine, into sine by which function? Not by which function, by which formula? Pi by 2 minus theta. Pi by 2 minus theta. Maybe you have to put here also. Correct only. You have to put pi by 2 minus theta only. I think formula you will be getting. What is x? Okay, sorry. Is equal to x. Okay, is equal to x. Now what you are going to do? You are going to multiply this total equation. You are going to multiply this total equation with in terms of sine inverse. Okay, sine inverse function. So then it will be, the sine will be cancelled out, and here sine inverse x you will be getting. So sine inverse x is equal to pi by 2 minus theta. So what is theta? Theta is going to be cos inverse x. Here we have got that formula. We have got the same formula. Sine inverse x is equal to pi by 2 minus, what is this theta? Cos inverse theta. Okay, cos inverse x. Sorry, cos inverse x. So yeah, if you transpose this to this side, exact same formula only you are getting. So that means amongst them you can choose any one. Okay, any one inverse trigonometric function, and then you can do. Okay, wow. Now we are going to prove for tan inverse. For everything you are going to choose only first quadrant. For every trigonometric function you are going to choose first quadrant, because first quadrant is what will be opt. Okay, then only you will be getting the desired formula. If in case you choose, okay, if in case you choose second quadrant and C, it will become plus now. Then if it becomes, if I'm saying, okay, you are not supposed to choose, you are supposed to choose only first quadrant. So if you are choosing this pi by 2 minus theta, if you are choosing pi by 2 plus theta, then it will be becoming as plus. Okay, if you are choosing second quadrant, then it will become as plus, right? Okay, so then apply cos inverse, you will be getting here also plus. When it goes this side, it will be minus. So that means you will not be able to get this formula. Okay, so tan inverse x plus cot. Okay, tan inverse x plus cot inverse x is equal to pi by 2. How are you going to prove this? Exactly the same way like you have proved over here. You are going to assume either tan inverse x or cot inverse x. What are you going to assume? Let us take tan even. Okay. So tan inverse x is equal to theta, and tan theta is equal to x. Tan theta is equal to x. So you are going to convert this tan theta into cot in terms of cot. Then how you will be converting cot? Okay, pi by 2 minus theta is equal to x. If you don't know these conversions, go and visit the previous video about trigonometry I have uploaded. Okay, not inverse trigonometry, about trigonometry I have uploaded. Then only this conversion will be very clear to you. Okay, crystal clear to you. It will be. Okay, so cot pi by 2 minus theta is this one. So now we are going to put cot inverse. Okay, multiply this total equation or this total formula in terms of cot inverse. So then this will be cancelled out, and here there will be cot inverse x. Okay, so cot inverse x is equal to pi by 2 minus theta. So what is this minus theta? Is equal to tan inverse x, right? So cot inverse x is equal to pi by 2 minus tan inverse x, which is equal to this formula. Okay. Next is also this same model formula only. I will prove this. Okay, this is not required now. Because this is what I've written over there. So we are going to prove this over here. I know you might say, why should I be this much confused with in terms of what? In terms of space. Well, the thing is, this smart board has only 32 GB of space, and already I've used about 16 something like that. Okay, 16 or 8, and if I keep on using a lot of pages and a lot of slides now, then this will catch a lot of space. Okay, so now we are going to prove sec inverse x plus cosec inverse x is equal to pi by 2. Okay, so if you have understood all those derivations very clearly, then also you would have guessed, at least you would have guessed how to derive this. Same thing only, you are going to choose either sec inverse x or cosec inverse x. Let us choose sec inverse x only. Sec inverse x is equal to theta. So then sec theta sec theta, oh gosh, oh, sec theta is equal to x. Okay, so now we are going to do the same thing. We are going to convert. Okay, we are going to convert. First quadrant will be, so sec pi by 2 minus theta is equal to x. What is x? X is sec theta, right? Okay, so what is x? X is sec theta. No. Why am I doing like this? Why can I multiply this total equation with sec inverse? The sec inverse function. With sec inverse function. Okay, so then automatically here this x would have become sec inverse x, and here this sec would have got cancelled. Then this pi by 2 alone, pi by 2 minus theta will be remaining. So then what is this theta? Theta is going to be sec inverse. Oh. Here cosec only should come. Here cosec only should come. Okay. So cosec pi by 2 minus theta is equal to x. Now we are going to multiply this total equation with cosec inverse. Okay, cosec inverse only we are going to multiply. I thought then even something is bad. So then that means this would have got cancelled with this one over here. Then here it would have become as cosec inverse x. Okay, so now we are going to do that. What I told you. So here it will be pi by 2 minus theta. What is theta? It is sec inverse x. It is sec inverse x is equal to cosec inverse x. Cosec inverse x. Okay, put this over this side, then you'll be getting this formula only. Okay, wow. 10, 10, angelic number, 11, 11, angelic number. Okay, now what we are going to see is we are going to see some other formulas, double angle formulas and triple angle formulas. We are going to see. Okay, we will do one thing. We are going to prove every literally. No, half angle formulas are not that much required. Plus or minus, yeah, plus or minus alone we will do. Plus or minus alone we will do. If here, let us do less or minus. Like here I have written like that, here how it will be. If here minus is there in terms of plus, if there is minus then here also there would have been minus and here there would have been plus. Okay. And also what is cot? Okay, what is cot? Okay, cot inverse x plus cot inverse y is equal to cot inverse of inverse of x dot y minus 1 whole divided by x plus 1. If minus is here, then here plus will be there and here minus will be there. That's the difference. One thing I have to say. Yeah, correct only. Okay, everything is correct only. How are you going to prove this? You can do it by yourself also, but I'm not going to leave that. Okay, so take cot x, take cot y, and then you'll be getting these two now. So you are going to prove this by using this one formula. What is that one formula? Cot x, cot of x plus y is equal to cot x dot cot y minus 1 whole divided by cot x plus cot y. Oh, okay, so this is the formula that you are going to use. Okay, so here what you are going to do, first you are going to multiply this total equation. This even will take, you take this formula itself directly. Okay, multiply this total formula in terms of, okay, in terms of cot inverse. If you are multiplying here, then this would have been cancelled, and here cot inverse will be there. Okay, here cot inverse will be there. Okay, so here it will be x plus y is equal to cot inverse of cot x dot cot y minus 1 whole divided by cot x plus cot y. Okay, ma. Now let us assume. Okay, let us assume that blue color will take cot inverse of x. Cot inverse of x is equal to a, and cot inverse of y is equal to b. So then x is equal to then cos a. Okay, then cos a is equal to x and cos b is equal to y. Correct? Then cos a is equal to this, and then cos b is equal to that. I'll write this in terms of a and b, then only for explanation will be clear. Okay, for explanation then will be clear, or else we will be confused. As I said that anything can be written in terms of y and x, or a and b, or z, something, some alphabets. Okay, you can convert them as per your wish. That's not something you need to worry at all. Okay, you need not to worry at all. Okay, I'll write this in terms of a. A B A B A B A B A B A B. Okay, ma'am. You got this. You have got this. Now all you are going to do is you are going to give input. Okay, this and this you are going to combine, and you are going to interchange. You are going to do some collaboration, and then you are going to get the desired formula. What is that formula? This is what that formula. Okay, so a, what is a? It is cot inverse of x. So it is cot inverse of x. Then what is b? B is cot inverse of y plus cot inverse of y is equal to, what is this? Yeah, cot inverse of, what is cot a? Cot a is x. What is cot b? Cot b is y. What is this? This is minus 1 whole divided by cot a. Okay, cot a is x, cot b is equal to y. You have got this. Then what else? Okay, I have written there even plus or minus. My ankle pains a lot, I don't know why. Now, what we are going to prove is we are going to prove some double angle formulas. Okay, so what are those double angle formulas? First, we are going to prove, what should we take? First, we shall take sine 2 theta. Okay, so sine 2 theta. First, I'm going to write all the sine double angle formulas in terms of tan and cos. Yeah, tan and sine and cos we will take. Sorry, sine and tan. Okay, so here you can write as 2 sine theta dot cos theta, or also there is another formula which is also equal to, okay, which is also equal to what is it? I forgot. 2 tan theta. 2 tan theta whole divided by 1 plus tan square theta. Okay, now it got to my remembrance. See, you got, don't think like, oh, these many formulas are there, how am I going to remember all of them? Go and see the previous video. I've even seen, even shown some shortcut tricks in order to remember all of them. Okay, so you have got this. How are you going to prove this? That is what the question. That is what the quest is. So sine theta, let us assume. Okay, so hereafter what you are going to do is, in every place, okay, in every place, sine theta is there now. So instead of sine theta, you can take, here since sine theta is what the subject is, you are going to take sine theta only. Okay, so sine theta is equal to x. Then if in case you are proving cos double angle formulas. That means cos 2 theta. Then you have to take cos theta is equal to x. That's it. If you are taking this itself, it's enough. Literally, you will be able to prove by yourself. Okay, I'll be showing just like 2 to 3 examples. Okay, so cos theta is equal to x. Then in terms, okay, in terms here. Okay, then in terms of inverse you are going to write, and also I will be suggesting you all to write see this video with 1.5x or with 1.25 or with 1.75. If you are seeing it in 1x, that's okay, it's your wish, you will be able to understand a lot more better than seeing in a faster version. But if you are seeing in faster version now, you will be able to complete this video within a short span of time than the normal persons who see it in 1x. Okay, because I'm changing like this color, all those things is right. So if I'm doing like that, automatically there will be some sort of problem. Because in a lot of YouTube channels, in a lot of big YouTube channels, what they do is they already do this PowerPoint presentation and then they just teach just like that and they'll be completing. But we are not doing like that, right? We are writing everything from A to Z. Yes, so you can see it in a faster version, so that you'll be able to complete part 1, part 2, part 3 in a very easy peasy lemon squeezy and within a short span of time than you would ever expect. Okay, so here you can write this as sine, okay, sine inverse of x is equal to theta. Okay, so how are you going to do this? What you are going to do is pretty simple. First, I'm going to take this one. Okay, actually this is not the required formula. This is what the ideal formula that I've taken in order to get the desired formula that we want. Okay, in order to get the desired formula that we want. Okay, so this also I'm going to convert. Okay, this also I'm going to convert in terms of sine itself. Then we can write in place of cos theta, we can write root over 1 minus sine square theta. Yeah, okay, so root over 1 minus sine square theta we can write now. So sine 2 theta is equal to 2 sine theta dot root over 1 minus sine square theta. Right? So in place of sine theta I'm going to put x. Okay, before that what I'm going to do is I'm going to multiply this total equation with sine inverse x. Sorry, sine inverse, just sine inverse function. So then this one and that function will be cancelled here, and here this sine inverse will be like as such. Okay, there won't be any change over here. Okay, so now I will be writing that 2 theta is equal to sine inverse of 2 sine theta is x. Okay, dot root over 1 minus x square. What is the sine square theta? Sine square theta is equal to x square. Okay, so this theta is what? Theta is sine inverse of x. Okay, so 2 sine inverse of x. Okay, so 2 sine inverse of x is equal to sine inverse. Okay, this will be writing in a different color so that it will be showing important. Okay, red always shows danger, importance, highlighting nature. Okay, red always has this highlighting nature. Sine inverse of x is equal to 2 sine inverse of x is equal to sine inverse of 2x root over 1 minus x square. Okay, so here we are going to discuss one shortcut trick. Okay, this one shortcut trick is enough to remember all the double angle formulas. Okay, but the thing is, to remember all these double angle formulas, you should have already known. Okay, inverse double angle formulas. To remember all these inverse double angle formulas, you should have already known these double angle formulas. Okay, then only this shortcut trick will be very, very, very efficient. Okay, if you don't know, then it is very hard. Then you have to go with normal derivation process only. Okay, so what is that shortcut trick? Very simple. Okay, very simple. We are going to take, okay, we are going to consider this equation. First rule of this shortcut trick is convert this cos. If here cos is then converted in terms of sine. Okay, if okay, there is no way that tan is going to be there. Okay, there is no way. But if in case there is tan, okay, there were tan, then what you are going to do? Then also you have to somehow convert it into sine. If any of the trigonometric values there, then convert it into in terms of sine. Okay, so now you have converted it in terms of sine. Okay, then that model you will be getting. Okay, that model. For an example, here, if you are converting cos theta into sin theta in terms of sin theta, then it is going to be cos theta is equal to root over 1 minus sin square theta, right? Okay, now what you are going to do is you are going to assume sin theta as an alphabet, like what we have done over here, like sin theta is equal to x. Okay, here it is what this x is what it is, the ratio of the sides of the triangle, the right angle triangle. Okay, so here that is what we have done over here. Okay, 2 is as such. Okay, 2 is over here also. Here 2, here also 2 is as such. Cos theta is being assumed here as x. Sorry, sin theta is being assumed here as x. And the converted cos theta into sin theta, over there sin square theta is there now. Okay, over here sin square theta should be there, right? Because cos theta is equal to root over 1 minus sin square theta. With this sin square theta, sin theta is assumed as x, so that means sin square theta is going to be assumed as x square theta. So here x square is there, and over here, coming to this side, any number, it need not to be just 2, any number 3, 4, 5, 6, whatever it is there, this will be coming over here. Okay, this will be coming over here when you are writing in terms of inverse. And you have to put here inverse, and you have to put here inverse, and here also you have to add sine inverse. Here also you have to add sine inverse. Then you will be getting this formula. Okay, so now what we are going to do is we are going to, if you have understood this concept now, we are going to prove some trigonometric formulas with this concept in sense with this type of shortcut even. Okay, so what is that shortcut? Just now I said that. Okay, so we are going to understand any one formula from here. Okay, see, everywhere if one in one place if it is y none, then in everywhere it is y only. Yes, right. If in one place it is y none, then in everywhere it is y only. Here also y, here also y. That is what I'm saying actually. If x is here, now convert them in terms of cos. Make sure that a cos inverse formula, if you want a formula for cos double angle formula or for formulas like this, then convert every part of that formula in terms of one trigonometric function. Okay, do not let any foreign trigonometric function to be there. Okay, that means what is the trigonometric function? This y is what the trigonometric function is. I have said right. Assume. Okay, assume. Okay, take this one. Okay, take this. Actually, this one is pretty easy. Okay, this one is pretty easy because only one inverse trigonometric function is there. But here two different inverse trigonometric function is there. Then what is the shortcut trick for here? It differs. Okay, when you are having two different trigonometric function, then the shortcut trick differs. Okay, first what you are going to do is put this tan over here, this sine over here. We are writing this. We are converting this inverse trigonometry. We keep this inverse trigonometric formula into trigonometric formula. Okay, so tan y. Okay, tan y is equal to not y, theta only should be there. Okay, theta only should be there. Okay, first we will try to convert this one. Then we will be converting this one. Then only will be more good to understand. If any alphabet is over here, what we have to do? We have to put it over here, and we have to cancel this inverse. Okay, we have to cancel this inverse, and we have to put that over there. So then it will be sine 2y. Okay, no, y you don't assume. You assume that as theta itself. Okay, you assume that as theta itself. Okay, so after this assumption of this theta is equal to, take this out. Okay, take this out. What is over here in place? What is here? Sine inverse only. Now it is there. So that means here this y is also going to be sine theta only. Is equal to 2 sine theta root over 1 minus y square is going to be 1 minus sine square theta. Is going to be 1 minus sine square theta. Now, when you're taking this formula, first, you are going to put tan over here, sine over here. So there will be tan y. Okay, sorry, tan theta. Convert this as theta. Is equal to C by basic common sense. I can say that tan theta is equal to sin theta by cos theta. That is what this formula is. From that only we have got this. But how is your question now? How can be your question? You have put this tan theta over here. Okay, tan theta over here. When you are converting this tan inverse to this side, okay, you have to put it over this side. Then tan inverse will become as just tan. Okay, tan. And also you have to neglect this y part and you have to put it as tan theta. So tan inverse is going here and it has become as tan theta. Okay, then put this y over here. You put this y over here. And how are you going to know what is y? How are you going to know what is y? That can be a question. Okay, so sine inverse y is equal to theta. Then y is equal to sine theta. So y is equal to sine theta. Mami varangla? Ippaya. Okay, so y is equal to sine theta. So tan theta is equal to, so in place of y, just now we know that it is what? Sine theta. So sine theta whole divided by root over 1 minus sine square theta. Okay, so which is cos theta. Root over 1 minus sine square theta is equal to cos theta, right? Okay. Next is this one. Put it over here, put it over here. That means, and here it is like mixture of this and this, a slight mixture of this and this. Okay, so first what you are going to do is you are going to take, okay, so tan inverse, okay, by saying I can say that this is cos 2 theta is equal to 1 minus tan square theta whole divided by 1 plus tan square theta. Now how is the question? So tan, this only you have to take, always take in this side, okay, this side, the LHS, sorry, the RHL side. Okay, always you have to take the RHL side, which is this one, right hand side, RHS. Okay, so tan inverse x is equal to theta. Then tan theta is equal to x. But the question is how? That is what the shortcut trick we are going to deal with. Okay, so put this over here. So and when you are putting this over here, what will happen is this 2 will be combined with the theta itself, theta of cos. Okay, so then that means cos to theta it will be becoming, okay, because what did I say? This 2 will come over here and then only the inverse will be cancelled out. Okay, so then is equal to, just now we saw what? X is equal to tan theta. So 1 minus tan square theta whole divided by 1 plus tan square theta. Okay, so now we are going to do 11. I guess we are going to complete with this angelic number. We are going to complete all the formulas. That is cos 2 theta is equal to, in terms of cos, now it will be 2 cos square theta minus 1. Then in terms of sin, it will be cos 2 theta is equal to 1 minus 2 sin square theta. Then in terms of, okay, tan, okay, so sin 2 theta in terms of tan, that is something which we have to prove over here even. Okay, we will prove, don't worry. Okay, so sin 2, okay, so sin 2 theta is equal to 2 tan theta whole divided by 1 plus tan square theta. With that shortcut trick even, we are going to prove all of them. Okay, then also we have got tan 2 theta. Yeah, so tan 2 theta is equal to 2 tan theta whole divided by 1 minus tan square theta. Yeah, so 1 minus tan square theta. Okay, so these are those we are going to prove with shortcut trick. Okay, with shortcut trick. What is that shortcut trick? Put cos inverse. Okay, so it will be 2 cos inverse x. Okay, wow. So 2 cos inverse x, which is equal to cos inverse of, okay, cos inverse of, what is this theta? Cos theta is equal to x. Okay, so cos theta is equal to x. That is what you have to always assume over here. So here cos square theta is going to be, here 2 should be there, here cos square theta net is going to be x square minus 1. Okay, x square minus 1. Here what you are going to do is put this sign over there, cos over here. Okay, ma. So then it will be 2 sine inverse x. Okay, so x is equal to cos inverse of 1 minus, okay, 1 minus x, 2x square. So 1 minus 2x square. What is this in terms of minus now? Yes, right. Okay, so this is correct. That is what I got a doubt. Okay, whether it was correct or it was wrong. Okay, now how we are going to do this? Same single step only. To this tan, sign over there. So it will be 2 tan. Okay, so it is going to be 2 tan inverse x is equal to sine inverse of. So here what you are going to assume is tan inverse x is equal to theta. So tan theta is equal to x. Okay, so tan theta is equal to x. Correct? So here we are going to give it as 2x whole divided by 1 minus x square. Okay, so this is what the formula that you are going to get. Over here, what is the formula that you are going to get? You are going to get okay, so tan inverse, okay, 2 tan inverse theta is equal to x, 2x whole divided by 1 minus x square. Okay, 1 minus x square is the formula that you are going to get, because here you are going to take tan inverse x is equal to, here x1 should come, here x should come, is equal to theta. So then tan theta is equal to x. So then tan theta is equal to x. Here, what you are going to do is, you are going to take it as 3 sine inverse theta is equal to sine inverse of, okay, so sine inverse you have to always put, here also tan inverse should come, here also tan inverse should come. Okay, here sine inverse of 3, okay, so 3x minus 4x cubed. Here what you are going to do, you are going to get 3 tan inverse of x is equal to, okay, tan inverse of x, here also x. Okay, so 3 tan inverse x is equal to 3, okay, tan inverse of what should be written in bracket? So what should be written over here in bracket? I'll write over here because there is no space over there. It is going to be 3x minus x cube whole divided by 1 minus 3 tan square. Sorry, minus 3x square. Okay, 3x square. So these are those shortcuts. Okay, these are those shortcuts, and yeah. So as I said that all these are very simple and easy peasy things. Maybe for you it might be a little bit, oh, what is this? But when you are doing when you are applying the shortcut for any one formula, then for remaining all formulas it will be just joopy. Okay, even I didn't expect these will be this easy for me. And also this shortcut I found it just by getting this derivation. Okay, when I got this derivation, then only I found, okay, so we can do like this, it seems. Then when I did, it came out perfectly, and also I checked in Google for this one whether it was correct or not, and it seems it was correct only. So it doesn't seem like it said it is correct only. I also checked in other places and the derivation says the same formula only, so you can use them. And also I'm so sorry for using some other languages and some other unwanted things during the video. Like sometimes family comes first, right? Okay, so we will be meeting in another amazing video. Till then, bye bye.